A bridge over a small creek around a marshy area needs to be repaired. The old design for the supports was good, but it's old and now needs to be redone in the exact same way. So we need to find the measurement of the angles and sides to match the old ones.
So how do we do that, Alex?
Well, the bridge was built with parallelogram shaped supports. Parallelograms are a quadrilateral with parallel opposite sides. A quadrilateral being a four-sided polygon and parallel lines being coplanar lines that do not intersect. There are a few theorems that will help us figure out what the measurements are.
Like theorem 6.3, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Also, in theorem 6.4, if a quadrilateral is a parallelogram, then its opposite sides are congruent. And also in theorem 6.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And also in theorem 6.6, if a parallelogram has one right angle, then it has four right angles, making it a rectangle. And in theorem 6.7, if a quadrilateral is a parallelogram, then its diagonals bisect each other. And lastly, in theorem 6.8, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles.
So this is the parallelogram that we need the measurements of. Note that all the measurements are in feet. We will start with the angles. Angle ABC is 70 degrees. Parallelograms give us congruent opposite angles. So angle ADC is cut in two. So all we need to do is take 70, subtract it by 36 to get 34 degrees. We use the theorem to get the angles on the other side. So that would be 36 and 34.
Now we need to find angle DAB, which is right here. Due to the theorem stating that a parallelogram gives us supplementary consecutive angles, supplementary angles equal up to 180. So all we have to do is subtract 70 and 55 from 180, which gives us 55. 55 plus 55 equals 110, which gives us angle DAB.
Angle DCB is found with parallelograms give us congruent opposite angles. So angle DCB is 110 degrees, with each of these being 55 degrees.
Now to find the side lengths, thanks to the theorem that states that parallelograms give us congruent opposite sides, AB is equal to DC, because DC is the opposite of AB, so it equals 2.5, and AD is equal to BC, and since BC is 3, AD equals 3, because they're opposite sides.
Now we can figure out these two sides with the theorem saying a parallelogram gives us diagonals that bisect each other. So EC and EB both equal 1.25. Finally, the angles that have E as their vertex. However, this is simple algebra as triangles equal 180 degrees. So doing the math, DEC is 89 degrees and CEB is 111 degrees. Then you can just use the vertical angles theorem to get the rest.
Note how you don't need to solve the problem in this exact order. You also actually don't need to use as many theorems as we did necessarily. For example, we didn't use theorem 6.8. However, it can still be a good way to check your work.
So now with all these measurements, we can fix the bridge.